All right, solving systems by graphing. We need to solve the system of linear equations. One method of solving systems is to graph both of the lines and look for the place where they intersect. Okay, if they don't intersect because they're parallel lines, or because they actually end up to be the same lines, then we'll talk about those special situations a little bit later on. Here's a nice, easy example. This will give you a good idea. We're just going to graph these lines. They're easy to graph because they're already in y equals mx plus b format. And we're going to look for the place where they intersect. So this one has a slope of 7, m value of 7, and it has a y-intercept of 7. So I come down onto the graph, plot my y-intercept at positive 7. And now if I try to rise 7 and run 1, I'm going to fall off of the graph here. So instead we're going to go down 7 and then go backward 1. I'm going to go down 7 again and backward 1. Okay, so I ended up with a positive slope, and it's quite steep. It's a slope of 7. All right, so connect those very carefully with a nice straight edge. This is one, this is a situation when you really want to be precise. You want to make sure you line everything up so that you get a correct solution. All right, now we're going to look at the second equation. We have a slope this time of 3 and a y-intercept of -1. So I can plot my y-intercept, -1. Whoops, I wrote 1 up here. I meant -1. We have a -1 y-intercept. All right, so here's our y-intercept is -1, and now I have a slope of 3. So we're going to go up 3. Let's see, 1, 2, 3, and over 1. Now we have a slope of positive 3. Rise 3, run 1. I notice that's actually taking me farther away from the line, and I'm trying to find a place where they intersect. So instead, I'm going to go down 3 and backward 1. Down 3 and backward 1. And right here, I've got a jackpot. This is the place where both of them intersect, because I actually plotted that exact same point when I was plotting both lines. So that would be x value of -2, y value of -7. So -2, -7 is our solution. Okay, and I'm going to go ahead and finish the graph. Did all that work? You might as well finish it. Okay, so now we can see that here are the graphs of the two lines, and that's the place where they intersect. That's our solution point. All right, let's take a look at another example. Okay, so that's one that you would see. It's nice and easy. You have no problem with those. Here's where it starts to get a little bit more difficult, and that's why you're watching this video. So let's take a look at this first example, this first line. This one is not solved for y. So in order to graph this, we're going to have to solve it for y. So we're going to do 2x plus 22y equals 17. I'm already having kind of bad feelings about this. I like the number 17, but I don't know how well it cooperates with either one of those numbers. So now when we subtract 2x, remember our goal is to be getting y by itself. We have 22y equals -2x plus 17. And then we divide them both by 22. So we now have y equals, all right, -2 over 22 is -1 over 11 times x. And then positive 17 divided by 22 is positive 17 divided by 22, which is, that's a lovely intercept. Would you like to graph that intercept of 17 over 22? And we can estimate it. We might as well go ahead and kind of roughly graph it and just realize that we are not being precise right now. We don't know precisely where 17 over 22 is. We do know it's a little bit more than half, than 1/2. That would be 11 over 22. But it's not quite 1. So maybe somewhere around 3/4. So there's our y-intercept. Now, we have a slope of -1 over 11. So if we were to go down 1 and then over 11, well, there's 10. So I don't know, somewhere right around there. Okay, remember, this is not a precise line. This will not give us an exact intersection point, but it will at least give us a good idea. And there we go. It'll give us a fairly good idea of where the point is, and then we can test it to see if that's truly the solution. All right, now let's work on the second equation. We've got x plus 11y equals -14. I hold out even less hope for this one. At least 2 and 22 might have done something okay with each other, but 11 and 14 were, it's not looking good. So we're going to solve for y. All right, 11y equals -x minus 14. We divide both sides by 11. We now have y equals -1 over 11 times x, and then -14 over 11. Okay, again, not real pretty to graph. So we have an intercept of -14 over 11. That's, like -1 point something. So if we go to -1 and a little bit more, or actually I should say a little bit less, right? Okay, now we're going to go down 1 and over 11. And guess what we kind of have here? What does it look like when we graph these lines? Do we see a solution? Do we see a place where they intersect? No, because it sure looks like they're parallel, right? How can we tell that they're parallel? Well, we absolutely know for sure that they're parallel because, oh, that's the wrong thing here, they have the same exact slope. So they both have a slope of -1 over 11, which means they're rising and running at the same exact, in the same exact way. So they are never going to intersect with each other. There is no solution to this system of equations. There's no place, no point where we can be, no set of x and y values that makes both of those true at the same time. All right, here's another one that could end up giving us a little bit of trouble. This one looks like, at first glance, like it's easy to graph. We have a slope of -4, and we have a y-intercept of, -16. All right, -16 means that I'm going to have to extend my graph here by a little bit. So remember, again, these are not going to be precise points, but at least they can maybe help us in getting our line started. So we've got -10, -11, 12, 13, 14, 15, 16. Now, this wouldn't work, if we had -27 or something like that. You'd have to go and get out some larger graph paper or, there's another method I'm going to show you in a little bit, but this one will work for now. So I'm going to go ahead and graph my y-intercept at -16. And now I have a slope of -4. Well, I don't think I really want to go down 4 and over 1. So instead of going down 4 and over 1, we're going to go up 4 and backward 1. 1, 2, 3, 4, backward 1. So we have to be really careful here. All right, we're at -1. And now up 4, 1, 2, 3, 4, backward 1. This is now our first official real point on the graph. We're not going to use those to draw our line because they're really not precise. But this one we know is the right spot. Now we're going to go up 4, 1, 2, 3, 4, and backward 1. Up 4 and backward 1. And, you know, we graphed the y-intercept, but this would be the x-intercept, and it was a very nice point. Let's look at that method in a second. Let's see, 1, 2, 3, 4, backward 1. And maybe we'll do one more. 1, 2, 3, 4. Just 1, 2, 3, 4, backward 1. Okay. Draw your line. Remember, we're not using those extra points that are off the graph. We're not really entirely sure of where they're supposed to be, but they did help us to get this into a more graphable location for us. Okay, so now let's take a look at our other one. In this equation, I see a whole lot of 5s. Solving for y means I'm going to divide everything by -5. So that'll give me y equals 5 over -5 is -1x. -1x. And 5 over -5 is -1. So we have a slope of -1 and a y-intercept of -1. All right, here's my y-intercept. If I go, let's see, slope of -1, I could go down 1, right 1, or I could go up 1 and then left 1 or backwards 1. So if I go down 1 over 1, I'm moving farther away from the red line. So I'm going to go with the second option, which is up 1, backward 1. Up 1, backward 1. It's kind of nice when the slope is 1. And there we go. We got a jackpot. That's the point that both of the lines are going to be using the same x and y value. So that's our solution point. And we've got plenty of points here to draw a nice line. Whoops, the blue one. All right. So that is, hopefully we've done everything correctly. And let's see. We have a solution point of 1, 2, 3, 4, -5. I have an x value of -5 and a y value of 1, 2, 3, 4. So -5, 4. Perfect. There you go, choice C. Okay. Now, we also had another option here. When we saw that we had an intercept of -16, and we realized that we really don't want to, maybe we don't want to extend our graph, maybe we're, for whatever reason, we're really not comfortable with doing that. We could check and see if we could find the y-intercept, the x-intercept instead. So let's take a look at that first equation again. Y equals -4x minus 16. The y-intercept is not really something I can graph easily, but maybe the x-intercept is. So remember, if we want the x-intercept, we're solving for x, we're going to make y equal to 0 and see what our x value equals. So if we add 16 to both sides, now we know that 16 equals -4x. So if we divide both sides by -4, now we know that x equals -4. So we have an x-intercept of -4. We could have graphed this red line a little more easily if we had found the x-intercept, -1, 2, 3, 4. We could have graphed that point and then gone back to that slope of -4 and started doing our rise and run. Rise and run. And we still would get this red line, but the x-intercept in this case was easier to graph than the y-intercept. That's fine. You really only need one point in order to start at. Remember that you have also one more option, and that is to just test a point and see if it makes both of those equations true. So we're going to come back to these. Let me erase this work right here. We're going to come back to the original equations, and we're going to just check this answer. It's kind of like guess and check. I'm going to plug that in for the x values. Anytime I see an x, I'm going to plug that in for any y's. So y equals, so that's 4 equals negative 4 times x. Negative 4 times negative 5 would be positive 20 minus 16. That is true. 4 is equal to 20 minus 16. So the first one is true. The second one, we have negative 5 times y. So negative 5 times 4 gives me negative 20. And it equals 5 times x. Well, negative 5. 5 times negative 5 is negative 25 plus 5. 5 minus 25 is negative 20, so it equals negative 20. So that's true. That means that our answer is correct. We just checked it. That's another way to solve the problem. If you really were stuck and you absolutely could not graph it, you could test out the points, and you're looking for the one where both of the equations are true when you substitute in the x and y values. All right, so there's, good 3 options to deal with kind of ugly graphs. All right, let's take a look at one more. I know, scary, scary. They're fractions, right? Okay, but if you kind of preview the answer choices, it looks like they're going to intersect right in an intercept. Maybe it's the y-intercept, maybe it's an x-intercept. So we always have that option. We could solve for the intercepts of both of these, see which one matches up. Remember, we're just looking for a point where they both match. We could plug in 0 for x and see it, and negative 7 for y, and see if they're both true. If they're not, we move on to another point. Okay? Or we could work with them as fractions. It's not going to kill you. All right, let's take a look at it. Let's look at the first one. I've got x plus 1/2 y equals 7. I'm trying to solve for y, so I'm going to subtract x from both sides. So I know that 1/2 y equals, remember I subtracted x, so negative x plus 7. Now I want to get rid of this fraction, so I'm going to multiply everything by 2. So now the fraction is gone. We have y equals negative 2x plus 14. Just make sure you're careful that you do every single term in the whole equation. All right, so now we have negative 2x plus 14. There you go with the falling off the graph again. So 14, let's see, 11, 12, 13, 14. Whoop. 12, 13, 14. Yeah, that's better. All right. And now I want to be moving down, so negative slope, that's good, down 2 over 1. Down 2, should be on the graph now, right? I had to go 4 units off the graph. I've made 2 slope steps, and I'm back on, so that helps. Down 2 and over 1, this should be good, right? We went down 4 and over 2. So negative 4 divided by 2 is negative 2. We're in good shape now. All right, down 2 over 1, down 2 over 1, down 2 over 1. Or remember that we could have solved this for the, instead of the y-intercept, we could have looked for the x-intercept. So if y was 0, let me switch to this magic pen for a second. If y is 0, well, 0, that would make the whole thing, negative half times 0 is also going to be 0. So if that's all 0, that's 0, that means that x equals 7, because x plus 0 equals 7. So we know that we have an x-intercept of 7. Get my red pen back. 1, 2, 3, 4, 5, 6, 7. And then I could use that slope of negative 2. I'm going to go up 2 and backward 1. Up 2 and backward 1. There you go. We could have used that to graph, or we could, create a little bit of extra graph up here. All right, now we're going to graph the other line. 1/5 y minus x equals negative 7. If the fractions are making you nervous, just multiply everything by 5. We're trying to solve for y anyway, so that's going to help us out. So we have just y, and now we have minus 5x equals negative 35. We're going to add 5x to both sides, so y equals positive 5x minus 35. And yeah, this is not looking like I really want to graph that one. I could extend the graph, by a couple points, but I don't really want to extend it by 25 points. So I'm not going to graph that y-intercept of negative 5. Let's take a look at what the x-intercept would be. Okay, so if y was 0, remember, let's go back over here. If y is 0, well, anything times 0 is going to be 0. So if negative x equals negative 7, that means that x equals 7. So when y is 0, I have an x-intercept of positive 7. Guess what? That's the same intercept. And now this one, if we were to continue our graph, has a slope of 5. We have to go back to where we can see the slope. So I could have started right here I could start at a x-intercept of 7. And now I could go up 5 over 1 and go down 5 and backward 1, because I know that you're fabulous students and you want to see this graphed. Oops. All right, so there's my blue line, and I'm only going to use true actual points that I know, so not those ones that are up there. And here you go. There's the graph of our two lines, and we can see that they intersect right here at the x-intercept of 7, because the x value is 7 and the y value is 0. So 7, 0, we're going to choose C. It's a little bit different method. Remember, if the y-intercepts aren't working out for you, they really weren't easy to graph, then we could go ahead and find the x-intercepts instead. All right, hope that helped.